Hello everyone, welcome to this video. What I'm going to do in this video is some problems from chapter 1, and I'll be using our textbook, Ross. I'll use the 9th edition, and if you have a different edition of the book, just make sure you're looking at the right problem. Anyway, I will read the question before I do it. Okay, big piece of advice before I start these problems. What I want you to do as you watch these videos is pause them multiple different times again and again until you get part of a question or the complete question. Write stuff down. Write down how you would start the problem or finish the problem if you have the whole question. Write down different ideas you have. Write down different pieces of information in short form. That way, you get going on the problem. Don't just sit there, watch a video like you're watching a movie. You have to pause, look at the problem, try it yourself. If you cannot get it, watch a little bit more, maybe get a little hint, pause it again, then try it again. Keep iterating till you can get the problem or you figure out where your difficulties lie, and then go and review that part of the chapter or review those topics before continuing on with the videos. That way you can use these videos as guides for practice as well, okay? And obviously if anything comes up that you don't understand or don't get, please feel free to email me or talk to me in class or after class or any such thing. Okay, so let's start now. We're going to do problem number 3. Chapter 1, problem number 3. We'll start with the basics. Okay, so what does the question say? 20 workers are to be assigned 20 different jobs, 1 to each job. How many different assignments are possible? So we have 20 workers and we have 20 different jobs. How many different ways can you assign these jobs to the workers? Well, the 20 different jobs are actual different jobs. You can give them names and arrange them alphabetically. Once they're arranged alphabetically, maybe give them short names. Let's say the first one is J1, second one's J2, third one's J3, all the way down to J20. Let's just write down the second last one also. And now you have the jobs arranged in order like this, okay? And you have 20 people huddled around, standing on the side, waiting to be assigned the jobs. How many different ways can you assign job 1 to somebody? There's 20 different people, so you have 20 choices. Once you've assigned job 1, how many choices do you have for job 2? 19. Now there's 18 people left over. Once you have assigned job 2, how many people left over? 18. So there's 18 choices for job 3, and so on. Now what do you do with these numbers? For every choice of assignment for job 1, you have 19 different possibilities for assignment for job 2. So it's like having 20 shirts and 19 pairs of pants. How many different ways can you get dressed? If you have no regard for fashion, then for every single shirt that you have, there's 19 different pairs of pants you could wear. So you could do that 20 times. So it's 20 times 19. Similarly, you would have multiply by 18, so on all the way down to 2 different jobs left for the 19th. 2 different people left over for the 19th job, and down to 1 person left over for the 20th job. So in all, this is 20 factorial as expected. Also the same number you'd get if 20 people ran a race. How many different rankings are possible at the end of the race? It's 20 factorial. Okay? All right. So let's do a slightly tweaked problem next, and let's call it 1.3 tilde. Okay, what I'm going to do is we'll still have 20 jobs, but they're not all going to be different. Let's suppose 3 of these 20 jobs are the same. I'm just going to call it job 1, job 1, job 1. And then the remaining 17 are distinct, okay? So in all, there's 18 distinct jobs, but these 3 are the same. How many different ways can you assign these to 20 people? Well, if these 3 jobs were different, we just saw from above, it would be 20 factorial, okay? but these three are the same. So just for instance, let's suppose you've assigned these to A, B, C, thinking of them as different. So maybe this is J with one line, this is J with two lines, and this is J with three lines, okay, for example. Okay, so let's suppose you've assigned that to A, this to B, and this to C. Or you could have ACB, or you could have BAC, BCA, CAB, or CBA. Okay, take a look. For any one of these 6 assignments, in the end, what you have is person A, no matter where, is just doing job 1. Person B is doing job 1, and person C is doing job 1. It doesn't matter. So what we have is we've overcounted by a factor of 6. Now, where does the 6 come from? That's the arrangement of 3 where order matters. So that is just 3 factorial. So we've overcounted by a factor of 3 factorial. So what do? You 20 factorial and you divide it by 3 factorial. And that's the number of job assignments possible if 3 of them were identical. Okay? All right. So let's now move on to question number 10. And let me know, like I said, if you have any questions. Okay. Question 10. What do we have in question 10? This is a 5-part question. So I'm going to read the main part and each part at a time and then solve that. Okay? So, in how many ways can 8 people be seated in a row if, part A, there are no restrictions on the seating arrangement? Okay, so there's 8 people, and part A, there's no restrictions. How many ways can you seat them? Well, we just saw, just like the 20 people running a race, this would be 8 factorial, right? Okay. Now, part B. If you have from these 8 people, persons A and B must sit next to each other. Then how many ways can you seat these 8 people? Okay, so how do you do that? You have persons A and person B, and you have 6 other people. Okay, what you can do is tie up person A and person B and think of them as one person. All right, and so now what do you have? You have 7 people to arrange. How many ways can you seat them? You can seat them in 7 factorial ways. A and B are seated either on a large bench or 2 seats stuck together. You can think of it like that. Okay, and now what do? Go to A and B and untie them and tell them they can swap around. So what can it be? B can be first, then A, or A can be first, then B. There's 2 factorial different arrangements for A and B, or 2 different arrangements. 2 is the same as 2 factorial. So for each of the 7 factorial ways, A and B could switch around. So what you need to do is first arrange all of the 7 units or 7 people, and then go to A and B, and then have them switch around, and that would be 2 factorial. So the answer is 7 factorial times 2 factorial. Okay? All right, and the same logic would hold if more people needed to be seated together. Okay, part C. What we have in part C is from the 8 people, there's 4 men and 4 women, and no 2 men or 2 women can sit next to each other. Okay, so how do you think of that? There's 4 men and 4 women. How do you seat them when no two men or 2 women can sit next to each other? So obviously in your mind what you're thinking is they need to alternate. Okay, that's correct. They need to alternate. Now, how can they alternate? They can start with men. Then men would be in every odd spot, and a woman would be in every even number spot. Or you could start with a woman, and a woman would be in every odd number spot, and a man would be in every even number spot. Okay, so let's just take the configuration of starting with men and see how many different arrangements there are. So how many choices for the first spot for a man? There's 4 choices. How many choices for the second spot? There's 3. How many choices for the third spot? There's 2. And how many choices for the last spot? There's 1. Okay, now let's take a look at the women. Same. How many choices for the first spot? There's 1. How many choices for the second spot? First spot, there's 4. How many choices for the second spot? There's 3. How many choices for the third spot? There's 2. And how many choices for the last spot? There's 1. So that's another 4 times 3 times 2 times 1. So you've arranged the men, then you've arranged the women. It's a multi-stage experiment, so you need to multiply it. Okay? So that is the number possible if the leftmost person is a man. Same argument, it's symmetric. You would have, once again, 4 factorial times 4 factorial, which is what that is, if the leftmost person is a woman. Okay, so the leftmost person can be man, or the leftmost person can be a woman. And you cannot have both. It's not a multi-stage experiment. So what do? It's either this or that. So you then add them. So the answer over here is 4 factorial squared plus 4 factorial squared, or 2 times 4 factorial squared. Okay? All right. Now there's 2 more parts here. Part D, it says there are 5 men and they must sit next to one another. Now, I'm sure you could do that with the same logic as we did in part B, where person A and B must sit next to each other. Now there's 5 men. What do? Tie them together. Think of it as one unit. And there are 3 women left over. And just give them 3 different wavy hairstyles. And now you can think of it as 4 units you need to arrange in a row. How many ways can you do that? It's 4 factorial. Now, what can you do then? After you've arranged that, you could go to the men, untie them, and they could rearrange amongst themselves in 5 factorial ways. First, you've arranged the units, then you've gone to the men and rearranged them. It's a multi-stage experiment, so it's 4 factorial times 5 factorial. Okay? In that case, if the women had to sit next to each other too, what would you do? You would have 2 units. Those 2 units can be arranged in 2 factorial ways. The men can be arranged together in 5 factorial ways, and the women can be arranged together in 3 factorial ways, okay? So just a little side comment. If men had to be together and the women had to be together. Okay? All right. That wasn't in the book. I just added that in. Okay, last part, part E. There are 4 married couples and each couple must sit together. Okay. So what do you have? There's couple 1 consisting of man 1 and woman 1. There's couple 2 consisting of man 2 and woman 2. Couple 3, man 3 and woman 3, and couple 4, man 4 and woman 4. How many ways can you arrange them in a row if they need to be seated together? Okay, well, tie them together just like this, and you can think of them as 4 units. 4 units can be arranged in 4 factorial ways. Okay, now over here, what can you do? The man can be to the left or the woman can be to the left in the first couple. So that's 2 arrangements. Same with the second, 2 arrangements or 2 factorial arrangements. Same with the third, 2 factorial. Same with the fourth, 2 factorial. You can have this and then tell the first couple to be arranged, then tell the second couple to be arranged, then tell the third couple to be arranged, and the fourth couple to be arranged. So it's 4 factorial times 2 factorial raised to 4. And I like to think of this as 2 factorial, not 2, because when you have bigger numbers, then you don't just make the mistake of thinking of it as a 3 instead of a 3 factorial. Okay, so I hope you got the same answer as I did. And I will stop this video for now and do a couple more problems in another video. Okay, so let me know if you have any questions. All right, bye for now.